Alright, so this is the Eurasian plate that I'm doing my presentation on, and yeah, so we'll just jump right in. The first thing that we're going to be covering is earthquakes. So we have some high seismic activity along kind of this area, and it defines, when you get down here at least, it defines the shape of the Eurasian plate. So it's prominent, it's most prominent in Southeast Europe right here. And well, it's more prominent clearly down there, but we'll get there. So Southeast Europe, along Italy here, you get some deeper earthquakes, and along Turkey here, you get more and more, and you hear devastating earthquakes happening in Turkey quite a bit. One happened recently, and it killed quite a few people. Along the border of the Indian plate here, you get a lot of scattered kind of service earthquakes, some deeper ones, 300 kilometers right there, but you get a lot of scattered ones across the Himalayas where those Indian plate and Eurasian plate come together. We'll talk more about that when we get to the elevation part of the presentation. And along the border of the Australian Pacific plates. And now this is where the most is happening here. You can see some really deep earthquakes. The green is 700 kilometers down. These earthquakes are happening. So when you get down there, you can see the shape of the plate happening along here, kind of in Indonesia, and all the way up through. Weaker earthquakes, weaker points of seismic activity are along the border of the North American plate, kind of where Iceland is, and the Great Lisbon earthquake. Now this happened probably right off the coast of Portugal and Spain, and what happened was it happened in 1755. It was a 9 on the Richter scale, rated a 9 on the Richter scale, and it killed 100,000 people in that area in that time, because it wasn't even as populated as it is today. But it's actually happening. It actually might happen again, which this was reported back in May 2019. It hasn't done quite anything yet, but it could. Now, serpentinization, that's called, hopefully I'm not butchering that pronunciation, is this act of the rock absorbing water, and it makes it weaker, causing the crust to potentially crack. And what happens then is delamination, which is where the sinking and loss of the lowest lithosphere layer from the tectonic plate which it was attached, it happens to weaken, and this is the first time delamination of the oceanic lithosphere has been identified. So it happened in kind of this area of, I'm sorry, I'm trying to make sense of all this information. It's a lot of different elements coming together, but basically you get a lot of this, here, let me put up everything, there we go. Now there is a particularly striking seismic activity under a seismically inactive area of the oceanic lithosphere, and that's what's worrying scientists, is this place where where an earthquake did happen in the past, and there wasn't for a very long time. It's now happening again because of these two things. And so a seismicity cluster is an area of considerable concentration of seismic activity, and they found one under that area, which is not good. But we're on to volcanoes. So in the west, we have most of the volcanic activity is in Iceland. Most volcanic, around and on the island of Iceland. There are still many volcanoes lining the border of southern Europe, such as along Italy and Turkey, such as Mount Vesuvius. And in the east, you have high volcanic activity along the margins of the plate that form paths that outline the Pacific and Australian plates. And the Pacific Ring of Fire is what you can see around here. That's the formation of the Pacific Ring of Fire, and I think it's along here or along here. I'd have to look at another picture of it. Anyway, so this covers the 2010 eruptions of Eyjafjallajökull. I think I got that right. And it happened from March 20th to April 30th, April 12th. Not 30th, way too long. But this is the first phase that happened. It's a diffusive eruption, and it flowed olivine, basaltic, andesite lava, and it kicked up a lot of volcanic ash, and it disrupted flight patterns in the surrounding atmosphere. And the second explosion it caused a lot more problems with the volcanic ash. So basically what happened was, it happened beneath glacial ice, so because of that, the ice cooled the lava fast enough to where it made volcanic glass, and that's what was spewed up into the atmosphere. So you had this giant volcanic ash cloud full of glass shards flying around in tandem. It's absolutely madness, and it disrupted flight patterns disrupted the airspace over northern Europe and North America. So this is talking about the divergent boundary at the mid-Atlantic ridge. So it's the divergent boundary. This is we're talking about the age of the crust around the Eurasian plate, and along here is one of the youngest parts of it. So you get along this ridge, it's a divergent boundary, so it's spreading apart, so it's constantly creating new crust, constantly creating newer crust. And the oldest crust around the Eurasian plate, it's down way south on the border of the Australian plate, and it's 120 million years old. And relative to other parts of the Earth's crust, that's pretty old, but relative to the Earth's age, that's actually quite young. Like the Earth's crust, it circulates itself quite frequently over the course of its history. This is Mount Everest. We're talking about elevation now. So the elevation on the Eurasian plate mainly concentrated in the Himalayas. So in the Himalayas, what happened was, between 40 and 50 million years ago, the Indian plate and the Eurasian plate, they met and they pushed up on each other. And because they have the same rock densities, they didn't form a subduction zone, they just kept pushing up and up and up and up. And that's why we see them so high up, like Mount Everest. We'll get to that in a second. Yeah, Mount Everest. So, Mount Everest is the highest peak in the world. Pretty common knowledge. 7,646 people made summits by, 4,469 people made those summits. So you had several people climbing Everest in the same lifetime. So a lot of people do that, but what you see here is people line up to go to the top, but not a whole lot of people actually make it to the top. A lot of them either turn back or they